that right, Josh? Yeah. I'm excited. Okay, here we go. 7-4 answers. Answer number 7-4. Here we go. Numero dos. 81 to the 1/4. Raised to the 4th is 81 to the first power. Yep, 81. Number 4. 256. This exact same problem. To the 4th power. Raised to the 1/4. No. Is number 4. Is 256. Power on power, you multiply. And that's inverse property. Anything times its inverse is 1. Numero 6. 8 to the 2/3. 8 to the 2/3 is the same thing as saying the cube root of 8 squared. It is calculator work or it's mental math work. I don't know what it is for you. For me, I would do mental or calculator. You pick. But hey, you need to recognize that's cube root of 8 squared, which is 4. Number 10. Number 10 is x to the 1/2 times x to the 1/3. Someone asked me yesterday, Mr. Bush, can I write it like this? The square root of x times the cube root of x. You can, but that doesn't help us. Here's why you need to recognize the benefit of knowing both forms. Follow me. We talked about how you could add radicals if they were like radicals. We talked about how you can multiply radicals if they're a common root, like you multiply the radicands. These are not common roots. This is a square root, this is a cube root. So there's nothing I can do when they're in radical form. You see that? Nothing I can do here. But when they're in exponential form, my exponential property says, what can I do? What do we do? What would the answer be? X to the 5/6. What we do is when you multiply a common base, you add the exponent. That is a property. It's on the wall. It's in your book. But hey, I can't get x to the 5/6 this way. But I can get x to the 5/6 here. So the advantage of exponential property, or when you use exponents, is I can use a property just to combine it to x to the 5/6. All right. So sometimes it makes the problem simpler to go that route. 14. 1/16 to the 1/4. You could tie it in your calculator. It's the same thing as saying the 4th root of 1/16. 1 has a 4th root and 16 has a 4th root. So I can get all the radical gone. I don't have to worry about rationalizing the denominator because 16 has a 4th root and 1 has a 4th root. So there you go. And you can tie that into your calculator and it'll give you the answer also. 18. We did this one together, did we? 12y to the 1/3 over 4y to the 1/2. You have 3 over y to the 1/6. Is that right? Okay. 22. Y to the 2/5 times y to the 3/8. Same thing as what we did right up here on number 10. You multiply a common base, you can add the exponents. Somebody help me. That'd be y to the what? That's 0.4. That's 0.375. Or what'd you say, 31 over 40? Yeah, this would be 5 times 8, so 16 and 15. Yeah, 31/40. Yeah, good job. 26, let's go to that. 26 has a 2x to the 2/5 times a 6, x to the 1/4. You multiply the numbers, you get 12, the common base of x times x. That's 0.4, that's 0.25. So that's 0.45, right? So how many 20ths is that? How many 20ths is that x to, how many 20ths did you get? 13? 13, well, 0.4 and 0.25 is 0.65. That's why it's 13 20ths. There we go. Yes. 0.65 is 13 20ths. Right? It is. Yes. Very good. And 30. 30, it gets a little easier here. You're just rewriting it in radical form. There is parentheses, so the whole 2y is being raised to the 1/3. So you can write it as the cube root of 2y. It's going from exponential form to radical form. (34). We have a very similar one, AB, all in parentheses, so all of it being raised to the 1/4. What do you think our answer should be here? Fourth square root or fourth root? Fourth. There's not a fourth square root. Fourth root of what? A and a B. Ab. Your abs. I do. One big round one. I like it. It's a good one. Nothing. Yeah, me and my son laugh. He got this body spray for Christmas, and they have like these weird names. He got like a pack of three, 3 different. One of them's name is really ripped abs. So we laugh like neither one of us have really ripped abs, obviously. But we spray it on ourselves. We're like, oh yeah, now we got really ripped abs. Which means it's just a stupid joke we do every morning. Okay, here we go. I'm glad that's being recorded and can be put out there for somebody else to. Yeah. 38. Where are we at? 38. This is the square root of x to the 3rd. Can be written in exponential form as x to the 1/3. Almost. X to the 3/2. Square becomes the denominator. Where's the third? It's understood square root, so that would be your denominator. 42. The 4th root of b, I wrote a 4. The 4th root of b to the 3rd power. How would we rewrite that? B raised to the 3/4. And the last one, 46. The 4th root of 5ab to the 3rd. It would be what? And Mr. Bush is incorrect. I don't know. Wait, actually, did y'all write that? 5ab to the 3/4? You are incorrect. That's right. Thank you. If I did not put parentheses, it would be incorrect. Because there is a huge difference in 5ab to the 3/4 and 5ab to the 3/4. Yep. That's right. This problem right here, actually, write this problem in radical form. Because this and this go together. So what radical expression would 5ab to the 3/4 come from? I'll give you 10 seconds. See if you write it. 5, 4, 3, 1. Did you write 5a to the fourth root of b to the third. That is how you would write that in radical form. The b only is raised, or the b only is the fourth root of b to the third. The 5a would just be there. So if I took a problem like that, where all of it's being fourth rooted, then to the third power, I have to make sure I put parentheses. That looks like a really good test question. I'd star that and put a heart on it and 2 smiley faces and whatever else you want to do to make sure you memorize, remember to study, something like that.